In Python, numeric data types are used to represent numerical values. They allow for the storage and manipulation of numeric values, enabling mathematical operations and calculations within programs. Python supports three main numeric data types: integer, float, and complex. Integers in Python represent whole numbers, including positive, negative, and zero. Unlike some languages, integers in Python have no predefined size limit. This means they can grow as large as the available memory allows. For examples, x equals 55, y equals 0, z equals -6. In Python, the float data type represents floating point numbers, which are real numbers with a fractional or decimal part. Floating point numbers are used to represent and perform calculations on non-integer values. For examples, x equals 20.0, y equals -2.5, z equals 0.0. Floats can be represented using scientific notation, especially for very large or very small numbers. For example, the e in 1.5e9 stands for exponent, which is a way of expressing power of 10. So 1.5e9 means 1.5 times 10 to the power of 9. In Python and many other programming languages, doing math with decimal numbers might not always give the exact answer. This happens because computers can't represent decimal numbers perfectly in their binary system. This can sometimes result in unexpected behavior when performing arithmetic operations. For example, the result of the sum 0.1 plus 0.2 in Python does not exactly equal 0.3. This happens because Python can't precisely represent numbers like 0.1 and 0.2 in its binary system. Python has to store these decimal numbers in a way that is not completely accurate. So, when Python stores these numbers, it has to round them off a bit, which creates a tiny error in precision. To solve this problem and obtain accurate decimal representations, we can use the decimal module, which provides a way to represent and perform arithmetic operations on decimal numbers with high precision. Here's how we can solve the problem using the decimal module. We first import the decimal class from the decimal module. Then, A is assigned the value of 0.1 and B is assigned the value of 0.2. We give float values to variables A and B using the decimal class. Finally, we print the sum of A and B, which accurately outputs 0.3. It's important to note that the decimal class receives the float value as a string input argument and returns a decimal object that represents the float value. The decimal module can accurately represent decimals and fix the accuracy problems found in floating point math. But operations with decimals can be slower than with floats because they handle higher precision. Also, decimals may use more memory than floats. In Python, the complex data type represents complex numbers, which consist of a real part and an imaginary part. Complex numbers are written in the form a plus bj, where a is the real part, b is the imaginary part, and j represents the square root of -1. There are two main ways to create complex numbers in Python. Using the complex function, this is the most common way. The function takes two optional arguments. The first represents the real part, and the second represents the imaginary part. If only one argument is passed, the function assumes that this argument is the real part and sets the imaginary part to 0 by default. Here are some examples. In the first line, 3 is the real part of the number and 2 is the imaginary part. In the second line, we use the function with an argument, where the imaginary number is set to 0 by default. In the third line, we set the real number as 0 and the imaginary number as 5, making it a purely imaginary complex number. Using literal notation, Python 3.6 introduced a simpler way to create complex numbers directly. We can use the j suffix after a number to denote the imaginary part. For instance, z equals 5 plus 4j. We can separate the real and imaginary parts of a complex number using special properties called .real and .imaginary. Here's an example. Print z.real. Print z.imaginary. Complex numbers support various arithmetic operations, including addition, subtraction, multiplication, division, and exponentiation. Here's an example that demonstrates some of the operations with complex numbers in Python. However, floor division and mod operations are not allowed for complex numbers. Complex numbers are not as commonly used as integers or floats in everyday programming, but they are crucial for specific domains including signal processing, control theory, quantum mechanics, electrical engineering, and more. Augmented assignment operators in Python are shorthand operators that combine assignment, the equals sign, with arithmetic operations. They allow you to perform an operation on a variable and assign the result back to the same variable in a single step. This not only makes your code shorter, but also slightly more efficient. Here are the common augmented assignment operators in Python. Addition assignment. X plus equals y. Adds right operand to the left operand and assign the result to left operand. Subtraction assignment. X minus equals y. It subtracts the value of y from x and assigns the result back to x. Multiplication assignment. X asterisk equals 4. Multiplies the variable by a value and assigns the result back to the variable. Division assignment. X slash equals 4. Divides the variable x by 4 and stores the result back in x. Here's how to use these operators for raising to a power, mod, and floor division. Using augmented assignment operators can make code more concise and readable, especially when performing repetitive operations on variables. They are commonly used in loops, mathematical computations, and data manipulation operations.